In the early embryonic circulation, the blood vessels were paired. Later on, some of these become unified by various mechanisms. Let's make a scheme demonstrating which of these blood vessels will be unpaired and which paired. I will use two different colors to discriminate between the unpaired and paired vessels. Let's start with the heart. We know we got just one heart finally, so the heart tube is unpaired, while the aortic arches are paired. So we got left and right aortic arches. Again, the dorsal aorta is unpaired. So is the vitelline artery. Then the umbilical artery is paired. We got left and right umbilical arteries. While the umbilical vein is an unpaired structure. Okay. So let's label the blood vessels. The heart tube, paired aortic arches, unpaired dorsal aorta, unpaired vitelline artery, to prevent misunderstanding. Unpaired in this context means we don't have later on left and right. But actually, there are more vitelline arteries. It's not a single blood vessel. It gives rise to the celiac trunk and to the superior mesenteric artery later on. That's why we want to know this one. We got paired umbilical arteries. The umbilical arteries also undergo significant remodeling. They connect later on with the common iliac artery. They give rise to the inferior mesenteric artery. The proximal part of the umbilical arteries persists as the artery you know as the internal iliac artery and the superior vesical arteries. After birth, it turns to the medial umbilical ligaments, the umbilical arteries. And the umbilical vein, there's only one, because the right one will disappear. The left umbilical artery, that's the one that persists. And after entering into the embryonic body, there are two vascular routes. One will one will carry the blood into the liver sinusoids. The other one is a shunt using a vascular connection called ductus venosus that carries part of the blood directly into the inferior vena cava without passing the liver microcirculation. After birth, the umbilical vein turns to the teres hepatis ligament, while the ductus venosus turns to the ligamentum venosum. There are more mechanisms of this unification. Let's illustrate the one of the dorsal aorta. So we got a cross-section through the embryo with the neural tube, neural crest, with the notochord, and originally a pair of dorsal aortae. This is the endoderm and the somites. While the vascular tubes will come close together and they will fuse together. So later on it looks like this. So this is the paired left and right. Aorta, but they move closer, so finally they fuse. The two tubes will fuse. A similar process occurs in heart. Originally there were two heart tubes. But they will touch in the midline and they will fuse together. Now this is the outflow part, and the inflow part receives three pairs of veins that we already know. It's the common cardinal vein, it's the umbilical vein, and it is the vitelline vein. And again, it's the vitelline vein, umbilical vein, and the common cardinal vein. So this is a scheme of the fusion of heart tubes. This is the right side, this is the left side, the anterior view, okay? And this is the common cardinal vein. Carrying the blood from the body of the embryo. This is the umbilical vein, carrying the blood from the placenta, and this is the vitelline vein, carrying the blood from the yolk sac circulation. And again, we got the vitelline vein, umbilical vein. Here is a symmetrical situation, and the common cardinal vein. Moreover, the unified dorsal aorta has several branches, segmental branches. So this is the neural tube with the neural crest and the notochord below. That will be the dorsal aorta, the unified. Should label this. And ventrally we got the intestine hanging on the dorsal mesentery. This will be the coelom cavity, right? So let's consider these segmental branches. We got left and right dorsal segmental branches, or dorsal branches with a segmental arrangement. But as they run in between the body segments called somites, the arteries are actually called dorsal intersegmental arteries. That you might know later on as the intercostal arteries or the lumbar arteries that retain this segmental pattern. We got lateral segmental branches that represent the blood supply to the embryonic excretory organ called mesonephros, which is again a segmentally arranged organ. We'll talk about it later. It's a large embryonic organ, but now we care about these lateral segmental arteries. Some persist and increase as the renal arteries, left and right, and the suprarenal arteries. That could be variable. We should not forget the ventral branches supplying the GIT. That give rise to the celiac trunk and the mesenteric arteries. So these were the branches of the dorsal aorta.